Okay, so we're going to be doing 3.2 and then a couple of these ready problems. The number 3 and number 4 and number 5 are all kind of lumped together, so we're going to do those. So it says use the graph to write the equation of the quadratic function. So whenever you're writing the quadratic function, it's always interesting because if you're writing the equation for a line, it's very like straightforward. For the most part, people are using y equals mx plus b, right? And you have to find your m, then you find your b, and then you're pretty much done. But for this here, for the quadratic function, you have a couple of different options that make it a little bit like a choice, like what would you rather do? And the choice comes basically for me is what did they give me? Okay, so let's go over your different forms first. So the first form that I'm thinking of is vertex form. So the very first form that they give me is vertex form. Okay, and what vertex, it's going to show up here in a little bit. What vertex form is it's you literally can look at it and be like, boom, there's your vertex. So here goes, looks like this, y equals x minus h squared plus k. And then we put this a out in the front here, and that's your multiplier. That's the thing that's going to make your function skinny or fat. So just notes really quick, h comma k is your vertex. Okay, so if I'm given a picture and I can pull off the vertex relatively quickly, I'm probably going to use vertex form. The next form that is really helpful is called factored form. And it looks like this, y equals to a parentheses x minus, I can't erase, x minus, I don't know, I'm going to use, they don't really have a number here. So I'm going to use m. I don't know what number to use right there. X minus n. Okay, where m and n are your x-intercepts, where x-intercepts at m and n. Okay. And then there's the standard form, which I don't really use. I mean, I will use it, but it's kind of the form for me. That's only useful. I mean, no, that's not true. It's the form that they give you all the time, right? So it looks like this, y equals ax squared plus bx plus c. So it's the form that you most likely will see most of your equations written in. And one of the useful things is that you know that your y-intercept is c. Okay, so each of these, depending on what they give you, I will use like that. Does that make sense? So like let's look at this one here. See how I can't tell what the vertex is? I wouldn't use vertex form here. So the vertex again is the point, the lowest point or the highest point, but I can't tell what it is exactly here. So I'm just guessing, and I don't want to guess because they want an exact equation. So for this one, I'd probably use factored form. Actually, my preference is to use factored form first, and then the rest of them, just because, I don't know, it looks a little bit nicer. So I'm going to do number 3. So number 3, I would definitely use factored form. You can also use vertex form if you want, but I'm going to use factored form just because, I don't know, that's kind of my preference right now. Okay, so the first thing that I'm going to do is I'm going to pull off the the x-intercepts, and that's this guy right here and this guy right here. So it says x is equal to -6 and x equals -2. Okay, so one of the things that you may remember from integrated 2 or last year is if x equals -6 and x equals -2 are your solutions, your x-intercepts, your roots, your those things, right? Then you have to think, okay, well, the line before that, right? And I'm going to go down, but it's the line before that looks like this. X plus 6 equals to 0 and x plus 2 equals to 0. So if you're wondering why I would do this is because a long time ago, you guys all learned how to factor things, and then you would go this way. So just give me a second and it'll make sense in a second. And then the line before that looked like this. It was x plus 6, x plus 2 equals to 0. Now, some of you are already seeing where I'm getting this x plus 6, x plus 2 business from our equations. So this is actually it. Okay. So I'm gonna take you back to integrated 2 really quick, just so that you know where I'm coming from. In integrated 2, I would give you a function that looked like this: x squared plus 8x plus 12, and this was your equation. And I said, okay, I need you to factor this thing. And so you knew, when I tell you to factor this thing, number one, I want this equal to 0, and I want factors. I want it to look like this. Now, depending on who your teacher was and how they taught you how to factor, I teach the X and then the array method. So you're thinking of what two numbers multiply to get to 12, but then add to get to 8, right? And so you're like, oh, that's just X plus 2, X plus 8, right? And then I'm like, yeah, okay, then what do we do? Well, then you would incorporate the zero product property, which basically shows this. This is what the zero product property says. The zero product property says, and this is you back in 3rd grade, 0 is our favorite multiplication table because anything times 0 will always give me 0, right? And this is going to catch up. Sorry, it's just a little on the slow side. So then what we do is we set both of those things up to 0. Oh, I put an 8 there. What did I put in 8? So then I set each thing equal to 0. And then I say x is equal to -2 or -6. So do you see how here we start with an equation and then we end with our x-intercepts? Here we start with our x-intercepts and then we end up with this equation. So Ms. Johnson, do you want me to multiply it out so it looks like this? You can if you want, but this is the equation that they're looking for. So the answer for this one is just, let's see, let's put it over here. Y equals x plus 6, x plus 2. Okay. The last thing that I'm going to do is I need to figure out if I have an A right there. And so I actually need to scoot this guy over. I need to see if I have an A. Oops. If there is an A, and I should have left some room, but I didn't. If an A goes there, okay. If an A happens to be there, I'm looking for that multiplier. And so I will tell you right now, it looks like there's a multiplier. I don't know. I can't tell you. I know that there's just a multiplier. I'll just put it like that. It looks like there's a multiplier because of how the numbers are all spaced out. So the way I'm going to do this is I'm going to plug in my vertex or my y-intercept, just a good number that I can plug in. And that's the number that I want to come out with. Okay. So this is now me, and I can scoot this over. Let me go down here. This is me now checking for an A, and I'm going to use my y-intercept because I like plugging in 0. Right? I like plugging in 0, and I should get out 6. I should get out 6. If I don't get out 6, then I did something wrong. Okay. Okay. So here's me plugging in. I'm going to plug in 0. So I got 0 plus 6, 0 plus 2. And so that I'm pretending there's an A out here is equal to 6. Now, if you look, all I did is I plugged in 0. And I'm trying to get out 6. Okay. So 0 plus 6 is 6 times 2 times A equals to 6. Well, that's 12A equals to 6 divided by 12 divided by 12. A equals 1/2. So this 1/2 right here goes right here. Ms. Johnson, how did you know to put a 1/2 there? You're supposed to check. That's why each of these has an A, an A, and an A, and their role is the same in all of them. It's to make your parabola skinnier or wider. Do you see how wide this one is compared to, say, this one? See how wide it is? The scale is the same, right? The scale is the same. So in case you're like, oh, but Ms. Johnson, we stretched this graph out. We stretched out the picture. Not not in this case, because look, your scale is the same, right? Okay, so here's your answer. And then I would want to check one more point, because checking one point is good, but in a quadratic, you got to check multiple points. So I'm going to come over here to my very favorite Desmos friend. He's my favorite. And I'm going to plug this in. I'm going to say 1/2 parentheses x plus 6. Oops, that's not how I want it to look. Parentheses x plus 6, close open, x plus 2. And this is great. You can either use your graph, and you can kind of like point in it and you're like, oh yeah, look, it matches. You can point on this one. Oh, look, -4, -2, -4, -2. Right here, -2, 0, that matches. And 6, 0, that, I mean 0, 6 rather, 0, 6, that matches. So I can actually plug them in algebraically to make sure if I want. You don't have to use your graph, but that's essentially what I'm doing. So if I plug in -4, I want to get out a -2. So I'm going to plug in a -4. And again, the value in checking your answer is the value in having confidence in knowing that you are right. So look, I got out a -2. I'm fantastic. Yay, Miss Johnson. So Miss Johnson, if you were to do this and use the vertex form, would the math be the same? Yeah, except for here, you just pull off your vertex. So I will do this in vertex form just for this. I'm going to do this one both ways just so you can see both ways. And then we'll move that through. So let me move all this work. Yeah, let's just move all this work here. I'm going to take all this work and I'm going to move it over here for you later, so you can be like, oh, that's where it is. But now I'm going to do it using vertex form, just so you guys can see. Okay, so here is a line. I'm just going to draw a line so that you guys all see this is the difference. Okay, so here, this is vertex form. And the way it works is it goes y equals a parentheses x minus h quantity squared plus k. And I'm going to steal this vertex right here. So this vertex is -4, -2. And I'm literally going to plop them in to h and k. I'm literally going to plop them in. So it's going to look like this: y equals a parentheses x minus parentheses squared plus blank. So I'm going to take this point here and put it here. And I'm going to take this -2 and put it right here. Okay, so -4 and -2. And you're pretty much done, except for now you just have to figure out that a. But you would do it in the same exact fashion by plugging in an x value and finding the y value, or the a value that would get the y value. Okay, so try and do that. Pause the video and try and do that really quick. Okay, so now that you're back, and now you can check this. What you're doing is you're plugging in a point, any point that you want. You can use, I wouldn't use the vertex because you've already used that point. You can use this x-intercept, but my favorite is to use the y-intercept because I'm going to plug in 0. Okay, so I'm going to plug in 0. Now I'm going to plug in the point 0, 6, right? Because it's 0 and it's 6 into this equation. So then I get 6 equals 2 a parentheses x, and I'm just going to say +4 squared minus 2. But this 0 is actually going to be x. So I'm going to put a 0 here. So I put this, oops, yeah, let's just leave it like that. Okay, so then 6 is equal to a times 4 squared. A times 4 squared minus 2, so that's 16a minus 2. And then I'm just going to solve. So that's 8. Oops. 8 equals 16a, which means a equals 1/2. So notice how our 1/2 here matches, oops, you can't see, our 1/2 here matches our 1/2 here. So you should get the same exact equation. So in vertex form, if you want a clean vertex form equation, our clean vertex form is y equals 1/2 parentheses x plus 4 quantity squared minus 2. So notice here, this equation here and this equation here look way different. Now, which one am I asking for? Well, number one, They just said write the equation for a quadratic function. They didn't say in factored form. They didn't say make sure that it's in standard form. They just said an equation. So I could use this one, I could use this one, and I'm still going to be right. Okay. Okay, I'm going to move this over here so that I can do some work with number 4. So this goes, yeah, let's put this here. Okay. Okay, so number 4, very similar work here, very similar work. So I told you before, should I use vertex, factored, or standard? I don't like this vertex right here because it's like in between. So I'm going to be using factored form. So the very first thing that you need to do is pull off your x and your y intercepts. I mean your x intercepts. So that's x equals to -4 and x equals to -1, which gives me x plus 4, x plus 1. And then I'm going to put an a out in front. Oops, it's not catching up to me. The computer is so low. Okay. There it goes. Okay, so then I'm going to set that equal to my y. And again, I'm going to plug in my my y-intercept because that's my favorite point to plug in. So I'll be plugging in 0, 1 into my equation to find out what my a is. So that means 1 equals to a parentheses x is 0 plus 4 and 0 plus 1. So that's 4 times 1 times a equals 1. So that means a equals 1/4. So my final equation is y equals to 1/4 parentheses x plus 4, x plus 1. And then I would check using Desmos. I would check using plugging in my points just to verify that I got those right. Okay. In general, when you're checking algebraically, checking 1 point is not good enough because you have to, it's actually a curve. And so if you think about, you already know that this is a quadratic, you'd need to check at least 3 points. So I would definitely take the time right now to plug in a couple more points. I tend not to use the points that I use to build it, so I wouldn't necessarily use x plus 4, x plus 1, but I would definitely plug it in if I have nothing else to check. Okay. I wouldn't check using my intercepts because that's what I used to build the factored form. I wouldn't use this intercept because that's what I used to build the a. But if you had no other points, like it doesn't look like I have any other good point. Actually, I have this point right here, -5, 1, which is the mirror of this point. But I would definitely check my answers. And that, again, that's the advantage of math, right? Because we get to check our answers. So the other problem that someone asked me to do was number 5. And so number 5 is this one here. Already you can see that it's an upside down a. I will use vertex form for this one because they gave me a clear vertex. And so I will be using vertex form for this. So the first thing that I'm going to do is I'm going to pull off my vertex, which in this case, my vertex is 0, 9. And then I'll plug it into my equation. So y equals a parentheses x minus h quantity squared plus k. And then I'm going to plug in my 0 and my 9 to a, h, and k. Okay, and then the rest of it stays the same. So I get y is equal to a parentheses x minus quantity squared plus, right? So I almost like plug that 0, 9 in there. And so now all I have left to do is actually find my a, which that's my multiplier. And I can tell you right now, it looks like my multiplier is going to be 1. Okay, and I can tell that because of how these extra little points are situated. Right. Okay, so just to verify, it's a good idea to verify. So I'm now going to use a point. Now I'm not going to use the vertex. Okay, I don't want to use the vertex because that's the point that I used to build most of my vertex form. So I'm going to choose another point. Another point I like to use is the x-intercept if I didn't use it. So I'll be using that. I'm now going to plug in the point 3, 0 into this. So I go y equals a parentheses x minus 0 squared plus 9. Actually, I'm going to get rid of that x. No, I'll just leave it. Okay, so now I'm going to erase and I'm going to plug in 3 for x and y for 0. 3 for x, y for 0. And then I'm going to calculate. Okay, so that's going to be 0 equals to a times 9 plus 9. So I'm going to subtract 9. So I get negative 9 equals to a times 9. And then a is negative 1, just like we said earlier. So when I said I knew that it was already going to be upside down, I already knew my a was going to be negative. And then when I look at my multiplier, it's a factor of 1 because of how these points are situated. All right. So then my final answer would be y equals to negative parentheses x squared plus 9. Now, Ms. Johnson, do you have to put those parentheses? No, you don't. You can actually just leave it as negative x squared plus 9. But I like to put it there because sometimes if you don't put it there, actually for the vertex form right here, it will be wrong. But because our x coordinate of our vertex was 0, we don't need it. Okay, last one. Number 8, it says in problems 1 and 2, the y-intercept is just the product of the x-intercepts. Why isn't that the case for 3, 4, and 5? The y-intercept is just the product of the x-intercepts. So up here, if we look at this, if we look at our x-intercepts, it's negative 2 times 3, which is negative 6. Here, right, we find that our x-intercepts are negative 4 times negative 1, which is positive 4. And then they said, why is that true for these, but not for these? Okay, so let's check. Negative 6 times negative 2 is 12. Nope. Negative 4 times negative 1 is 4. Nope. And then here, this one is negative 3 times positive 3 is negative 9. Nope. So why is that so? Well, if you look, these, well, we didn't do the answer for this one, but this one has an a of 1. These do not have a's of 1, but you can actually use that to calculate your y-intercept, right? So if you took your negative 2 times your positive 3 and you multiplied it by your 1, you get your y-intercept. Same thing goes here. Negative 6 times negative 2 is positive 12 times your a, which is half, which is 6. Negative 4 times negative 1 is positive 4 times our a, which is 1/4, which is 1. So the reason why they were not the same is because you have to take into account your a, your multiplier. Okay. All right. Have a great day.